Hey y'all, we're moving on the unit in working in polynomials, and we're going to continue multiplying them. And one of the neat things about multiplying polynomials is that sometimes you'll come across what are called special products. And there are really only two types of special products called perfect squares and conjugates, but we'll get there in a second with the vocab. I'm going to demonstrate this lesson through 7 different examples. And you can see they all look kind of peculiar, right? Each has a different look, and we're going to investigate what those looks mean, and then hopefully discover some shortcuts. So the first thing about special products that I want you to know is that when in doubt, you can always use the area model or the other methods, the old methods, I guess, to multiply. So these are shortcuts that are there for folks that can recognize. So if you can recognize what's happening, feel free to use these shortcuts. And I'll talk about the other methods by demonstrating number 1 and number 2. Okay, so we're going to multiply out number 1 and number 2, and we're going to use other methods first. We're going to see what's happening. So with number 1, we have this little expression that is x plus 5 to the second power. Well, what does that mean? That means x plus 5 times itself, times x plus 5. So that's what to the second power means, okay? And you can always use other methods to multiply this out. So if you want to use the area method, you totally can. So if you have an x and a plus 5 times an x and a plus 5, and you want to use the area method, you can completely do that. And hopefully you will see a pattern emerge after we work out number 1 and number 2 this way. Okay, so we have x times x, of course, is x squared, and then plus 5x here, and a plus 5x there, and then a plus 25 over here. Right, so we're using our old area model, and we can see that, well, that's plus 5x and plus 5x. That's interesting, I hope. I hope that's interesting. And then you have x squared plus 10x plus 25. So no matter what I show throughout this lesson, no matter what, if we multiply out this expression, x plus 5 to the second power, we're going to get x squared plus 10x plus 25. Always going to happen. This has a special name. We'll get back to it in a second. And so now we can take a look at the expression number 2 and see what's going on. So we have 2x minus 3 squared. And again, if you are uncomfortable with anything I'll show you in a couple minutes, you can always go back to this. 2x minus 3 squared is 2x minus 3 times 2x minus 3. And seriously, feel free, let's use the area model. So we have a 2x here and a minus 3 here, and then 2x here and a minus 3 here. And we can always use the previous methods of multiplying to see what's going on. So if you're not good with the shortcut or you're making sign mistakes, just stick with this, man. It's not going to do you wrong. I'm just here to provide a couple shortcuts. So 2x times 2x, of course, 4x squared, and then minus 6x here, and a minus 6x there, and a plus 9 there. And then you can see we have like terms right here, right? So minus 6x and minus 6x. Does not cancel, folks. Does not cancel. Negative 6 minus 6 is negative 12. And so that is our expression. Okay, so look at what's happened in this model here and in this model here, right? So, moving on to number 3. Number 3 is where we're going to discover a rule. So number 3 has something in common with number 1 and number 2 in that all 3 of these are binomials being raised to a second power. So these are all 3 binomials being raised to a second power. That means these are called perfect squares. Okay, so this is called a perfect square. And that is good to know. So get some vocabulary down. This is called a perfect square. Okay, so any binomial being raised to the second power is a perfect square. So what's going to happen? Well, if we have a and b here, and a and b here, and we use the area model, we're going to see something kind of cool pop up. And it's actually what we have already discovered. Okay, so we have a and b down each dimension, so we'd have a squared here, ab here. Now don't call that ba, folks. Don't do that. Don't do that. Don't call that ba. That's ab. Let's stick alphabetical, okay? We're going to stay alphabetic. And then b times b here is b squared. And again, as you can see, our like terms in the middle, and so we'd have, for our results, a squared plus 2ab plus b squared. Now, remember what happened. We multiplied perfect squares, and what did we get? We got this. So if we multiply two perfect squares, we end up with something, another vocabulary term called a perfect square trinomial. A perfect square trinomial. Okay, so when we multiply perfect squares, we get a perfect square trinomial. And take a look at this. Every perfect square trinomial follows this format. We'll talk about that in a second. Let's make sure we're doing well. So this was number 3, right? We had a perfect square, and we ended up with a perfect square trinomial, and it was a plus b to the second power, and it's a squared plus 2 times a times b plus b squared. Perfect square trinomial. If you can see patterns emerging, that's where you want to be, because then you can save a whole lot of time, but only if you're going to do it right. So now we're going to move on to number 4. Okay, we have a minus b to second power now, and that is also a perfect square. Okay, so this is also a perfect square, and again, we will see something kind of cool happen. So let's do the same thing. We have an a and a minus b here, and an a and a minus b here, and we can use the area model. Okay, so what will happen? What impact does that sign have, right? So we have a times a squared. A times minus b is minus ab. And negative b times a, again, folks, don't do that. Stay alphabetic. We're going to call that minus ab. Okay, stay alphabetic. And then we have minus b times minus b. Negative times a negative is a positive, right, plus b squared. So what do we actually have? We have our like terms here. And then we end up with a squared. Negative minus is like minus one of these, and minus one of these is minus 2 of them. Right? So it's minus 2ab, and then plus b squared. And again, this is also a perfect square trinomial. And we'll get back to this in a later unit, okay? But for this unit, this is just good to know. So remember, if we multiply perfect squares, we get a perfect square trinomial. So this is actually a shortcut. These two examples give us the insight to a shortcut. So let's go back to 1 and 2 super quick. If you look at number 1, we have x plus 5 squared. We can immediately jump to the formula. This is actually now a formula that if you're squaring a binomial where the terms are being added, if you're squaring a binomial that's adding terms, it follows this format, right? So if we're squaring a binomial that's adding the term, it follows the same format. The format is the first term squared, right? A squared, a squared, right? So hopefully you can see that. So a squared, a squared. The second term then is 2 times a times b. That means we're going to multiply a times b and multiply that by 2. Okay? So double a times b. So for this, we're going to double x times 5. So that's 2 times x times 5, or 10x. And then the last term, b squared, right, is, well, the second term squared. Of course, it's going to be plus, right? Plus b squared plus b squared. So plus 5 will end up being plus 25. Super shortcut, right? And so now what we have is a shortcut for a perfect square to a perfect square trinomial. All right? The same thing works. Remember what we had, by the way, the hard way. X squared plus 10x plus 25. Check, chickadee check, chickadee check. All right, so then did it work for number 2 as well? And if you remember, number 2 is 2x minus 3 squared. Okay, so we can apply the same shortcut. First term squared, 4x squared. 2 times the two terms multiplied together. 2 times 3 is -6, -6x, so double that, -12x, right? And then the last term squared, plus 9. Okay, so we can use that shortcut if you want. So it's okay, but remember you can always go back to using the area of rectangles. Okay, so it's no matter what, we're going to get the same result. I'm just trying to save you all time and space. And so that is the first type of special product. The first type of special product, called a perfect square. When you multiply it, you get a perfect square trinomial. And so that is how we have completely handled problems number 1, 2, 3, and 4, and you can always do that. Now you can see 5, 6, and 7 have a little bit of a different look. And like I said, special products only come really in two main sizes. You've got perfect squares and conjugates. So let's take a look at number 5 now. I'll get to the shortcut first. So 5 here we have a plus b and a minus b. So these two things have a name. They're called a thing, and we have to know that vocabulary. So when you have two terms where the only difference is one is plus and one is minus, that's a thing, and it's an important thing, and it's called conjugates. Okay, so these are called conjugates. Please know your vocabulary. It's going to make factoring a million times easier. So please know your vocabulary. These are called conjugates. Okay, so what happens when we multiply conjugates? So our first one, we have an a and a plus b. The second one, we have an a and a minus b. Okay, we can use the area model, and we're going to see something kind of cool occur. All right, so let's take a look. Well, our first rectangle, a times a, is still a squared. A times b is plus ab. And negative b times a, again, folks, don't do that. Horrible. Keep it alphabetic, right? And then the last term, what's a negative times a positive? A negative b squared. Okay, so we have this in our area model, and we look for our like terms. Plus ab minus ab, guess what that is? 0. Totally gone. Completely cancels out. No more. Right? So what are we left with? We're left with a squared minus b squared. So what just happened? We multiplied conjugates, and we ended up with this. And this also has a vocabulary term. This is called a difference of squares. Difference of squares. And if you notice, what's happening, difference, we are subtracting two perfect squares, a squared and b squared. And we subtract them, we end up with a difference of squares. That's what that, you got to know the vocabulary. I cannot emphasize that enough. Oh my goodness. So, that's what happened with number 5. Did we have to show our work? No. If you can recognize conjugates, go ahead and use the shortcut, right? Because you know conjugates multiply into a difference of squares. Yeah, 100% of the time. The shortcuts are only for people that can understand what's happening. And hopefully showing you this way will help you understand what's happening. Now that we have established that rule in this vocabulary that conjugates multiply into a difference of squares, we're ready to finish strong. Let's take a look at number 6. Number 6 was x plus 7 times x minus 7. And in the very beginning, it's all about recognize. Can you recognize what you're looking at? Do you recognize that we are dealing with conjugates here? You have to. And if you recognize that we're dealing with conjugates, well, multiplication becomes super duper easy. If you can't recognize what's happening, you can always go back to the area model or any longer method of multiplying. But the purpose of this lesson is to help you recognize things that are right in front of you. And then use some shortcuts. You don't have to. I'm telling you can. Shortcuts are for those that earn them and deserve them. Lastly, number 7, 3x minus 5y, 3x plus 5y. I hope you are recognizing that those are conjugates. And if those are conjugates, we end up with a difference of squares. 3x times 3x and 5y times 5y. How cool is that? Okay? So that is the lesson on special products. Remember, there's only two main types. We've got perfect squares that leave us with a neat formula. Perfect squares, if it's plus in the middle, plus 2ab. If it's minus in the middle, minus 2ab. And we have conjugates. Plus 1, minus 1, and then it multiplies the difference of squares. So that's it for the lesson. I hope you enjoyed it. Practice, 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 and then you get perfect. I'm out.